Let's take a look at problem number 18.9. It says a vertical tube 1 meter long is open at the top. It is filled with 75 centimeters of water. If the velocity of sound is 344 meters per second, what will be the fundamental resonant frequency in hertz? Okay, so we have a tube, and it's 1 meter tall. And it's filled with 75 centimeters of water. So it's mostly filled with water. So that really the part of the tube that's not filled with water is 0.25 meters, 25 centimeters. So that's the length of our open and closed end tube. .25 meters. Now, if we're looking at the fundamental, then the easiest standing wave we can possibly get is one which has an antinode at the open end and a node at the closed end. And that distance between the node and the antinode would be a fourth of a wavelength, a quarter wavelength. So the length of this tube is actually a quarter wavelength in the fundamental mode. That means that the wavelength is equal to 4 times the length of this tube. And so that's going to be 4 times 0.25, and that will be 1 meter. So that is the wavelength of the fundamental. And if we were to find the frequency, we know that the velocity of sound is equal to the wavelength times the frequency. So our frequency of the fundamental is equal to the velocity of sound divided by the wavelength. And that is going to be 344 meters per second divided by 1 meter, or 344 hertz. So that is the frequency of our fundamental, and the information that the tube itself was 1 meter long was extraneous information. It didn't have to be given, because the main part was what was the length of the open end, closed end part of the tube, and we had to use that to figure this problem out. So this is our answer, 344 hertz.